Alright, so in this life expectancy by decade problem for problem 25. Okay, so if we look at the graph of this, alright, we wind up with this guy right here, right? So I could try to bend that up. Let me see what happens if I try to bend that up. I'm going to go to, let's see, let's go to squared. We're going to go to L2 squared. And then we got to go to L1 versus L3. And yeah, it still has a little bit of a curve in it. So I'm not going to go down the ladder of powers because that's just going to bend it down. So I'm going to go to attack the logarithms, okay? So in L3 I'm going to do log, let's see, log of x, so log of L1. And then I'm going to do plot, I'm going to do, L3 is now my x value and L2 is my y value. So let's see what happens there. Alright. It's a little bit straighter, still has a curve on the end. So I'm going to go to L4 and then I'm going to do the log of L2. Alright, so I got an L3 log of x and an L4 log of y. Alright, so let's go and we're going to do L3 versus L4. And I actually drew the line there. Alright, so alright, so that looks decent. Okay, it's not perfectly straight, but it looks decent. So I'm going to go in and calc number 8, and I'm going to do L3 versus L4. So that's what our model would look like, it looks like. So how would we write that? Let's see here. So we're going to do log of predicted life expectancy equals 1.685 plus 0.185 times the log of the decade. Okay. Now if I go and I look at the residual plot, I get that. So that looks pretty random. Okay. So the other thing, what else do they ask us in there? So that would probably be it. I would probably use that model. Log of predicted life expectancy equals 1.685 plus 1.85 times the log of the decade.